In our last video, we looked at a data set that consisted of heights for a class from a high school in Texas. And that data set consisted of both male and female subjects. They were in the 12th grade. And we looked at the heights in centimeters, and we constructed these dot plots and put them on the same axis. So we scaled them on the same x-axis so that we could compare them. And we noted that there were data values that appeared to be outliers for these data sets. And in our video about box plots and outliers, we talked about the fact that sometimes outlying data values may merit some explanation. So let's examine the data values that we did determine to be outliers. We found this interval for the males, 125 to 192, and the interval for the females was 152 to 185. Let's look at the females first. For these females, we found these two particular data values from that data set, and we can see them here in the data set. Right here is the 62, a female that is 62 centimeters, and then here a female that's 78.74 centimeters. And they both lie outside of this interval. So let's think for a second about the measure 62 centimeters. If we were to convert this to inches and then feet, we would find that that measure is approximately 2 feet. 78.74 centimeters would be approximately 2 feet 7 inches. A quick search of the internet finds that the smallest woman in the world is just under 2 feet tall. So in examining these particular outlying data values, we can see that these are certainly mistaken data values, that they were entered incorrectly. If it's at all possible, we would go back and verify the data values. We would check and see, well, did we mean for this to be 162 centimeters maybe? And this one, did we mean for it to be 178 centimeters? Now examining the males, again, 67 centimeters is approximately 2 feet 2 inches. So this is certainly an error. 121 centimeters is approximately 4 feet. And a quick search of the internet will tell us that the average height for a male adult with dwarfism actually is right around 4 feet. So this may not be an errant data value, but the 67 certainly is. So perhaps it was intended that this would be a 167 centimeter measure. Now what do we do with these? Well, before we just go and correct them, we would, if at all possible, want to verify the values. So if we have access to the sample that was used to generate the data values, then we would just go back and check. Did we mean for this to be 162 and 178 and 167? So let's assume that we have verified the correct data values and found that these were supposed to be 162. 178.74 and 167. And looking through these data values, we can see that those measures would be in line with the rest of them, that they are consistent with these other measures. So now let's go through the process of constructing these dot plots again. So we'll click Graph, Dot Plot. Height is the variable that we want to examine. Group by gender. We want the point size to be 1 again. And just like last time, we will use the same x-axis. Click Compute. And now we get dot plots that look very different. Now notice that this range goes from 120 to 180. Before we corrected the data, our scale went from 60 to 180 on the x-axis, and then we had some data values that are actually greater than that. And after correcting, now it tightens it up quite a bit. Now the range is from 120 to a bit more than 180, as we can see here. The StatCrunch chose 180 as the last value to mark on the x-axis. In comparing the two dot plots on the new scale now with the corrected data values, we can see that some of the things that we talked about are still true. Overall, the height of the males appears to be greater than that of the females. We have a clustering around 170, where the females seem to have a spike just above 150, and then seem to be fairly evenly spread up towards the top. And then after performing the calculations for finding these endpoints for the outliers, we find the interval for the males to be 153.2 to 184.6. And we find the interval for the females to be 135.5 to 187.5. And looking at this female dot plot, we see that we don't have any outliers anymore for that data set. Examining the dot plot for the males, we see that we do have one outlier, that 121, but again, that may not be an errant data value as we discussed before. Now let's look up towards the top. There is one data value that does appear to be a little bit large. Let's look back at the summary statistics for that data set. The maximum value for the males was 186. That is larger than 184.6, our endpoint for our guideline for an outlier. But one of the things that we have to consider is that these guidelines for outliers are basically rules of thumb. So while that data value is a little bit larger than our right interval endpoint for an outlier for the males, it's not that much larger and probably shouldn't be questioned as a valid data point for the data set.